Hello, hello, hello. Welcome to this live stream. I hope you can hear me. I hope you can see me. And I hope the stream health is good. And if not, please put a comment in the chat or just write in the chat if everything is okay. It's been a while. I'm doing this live streaming and yeah, I need to set up my whole system for that. It took me hours to do it. But if you just write me a comment, if everything is okay, I would be happy to know if the stream is doing good. So I will keep an eye on the chat to understand if you can hear me and if everything is okay. And then we will start soon. Okay, everything is perfect. Thank you for your feedback. So in today's live stream, what I'm going to do is I'm going to use this book, which you can also see on my screen, Collection of Exercises for PLC Programming from Tom. So when Tom posted this book on the internet, I was very curious to know how I can solve these exercises because I was finding a way always to make it fun and engaging. Then I came across an idea that, okay, let's solve these exercises using Simumatik. So Simumatik is a digital twin platform which I can use to realize these exercises. So Tom, thank you for writing this book. And for those who don't know, today is Tom's birthday. So happy birthday for you. This live stream is dedicated for your birthday. It is such a coincidence. So before we begin, I would like to thank you all the audience who subscribed me because recently I crossed 100,000 subscribers and I got my silver button. So this is all because of you, because of your love and for sharing my video and appreciating my content. So without further delay, let's start solving the PLC exercise and feel free to write comment in the chat or in the comment box if you have any questions regarding that. All right. So let's begin with the first exercise. Actually, these exercises are very, very simple and I will start from scratch. So, you know, it's super simple, but that's how we begin. You know, there are some viewers which are programming PLC for the first time. So we will start really from the scratch. And you can also solve these exercises if you have any PLC software with you. You can use CODESYS, you can use Delta PLC programming software, ISPsoft, you can use CCW, RSLogix, or TIA Portal. Feel free to choose any software that you want. But if you want to follow me along with this tutorial, I recommend you to download CODESYS. So I'm using CODESYS as a software platform to program this exercise. All right. So, okay, some comments. Martin is saying, I think this next year is going to be 1 million. I hope it will be. That will be like a dream come true. So let's see. So beginning with the first exercise, we have very simple. Like I said, we have to turn on the light with a push button. Now, you know, I've always been using several tools to make things more interesting, to make things more lively to learn. That's my inner drive to be a content creator. So to solve this exercise, what we're going to do is we are going to use a platform called Simumatik to rely on PLCs and IOs. So let me open that now for you. So I will log into simumatik.com. So I'm already logged in. And there is an organization called Code and Compile. That's my company, or the name which I give to my work. So I will log into this organization using my account, but the Simumatik you can also try as a free trial version. You can sign up to Simumatik and you can also start building digital twins. So let's go inside. So I have to start my workspace. And once my workspace is running, you will see I will have a blank area where I'm going to put all the devices. So a task was to program a simple PLC with one switch and one lamp. Okay, so let's see how closely I can realize that. So in this case, let's go back here and I'm going to create a system. Although you can have multiple systems which are already created, you can load them. So I will create a new system. Let's call it PLC test bench, or you can call it any name you want to give. Our system is created. Inside this, I will add an assembly and let it be by default assembly. Inside the assembly, I will add a component. Now, first I want to have some PLCs, but before adding PLCs now, I need a table to put my stuff on. So I can go to a public library and let's see if we have a table there. We have a lot of table and let's take a work table. So we need a table to put our stuff. So the table is here. Now what we need a PLC. Very simple. Just go here, add component, And let's add a PLC. So we have PLC with 16 DIO and 8 DIO. So let's take a generic one with 16 DIO. And this PLC has been modeled already inside this platform. So all you have to do is just add the connections to it. Now the PLC starts from the 0 location here, so I can bring it up. And there you go, there is the PLC. So in the meanwhile, if you have any questions, I will answer that in the chat. So I will keep an eye on the chat. Okay, so that's my PLC here. And what do we need to do? Let's just rotate it and so that it looks nice on the table. And you can bring it down. There you go. So I have this PLC. Now, if you look at the diagram, what do we have? We have to have a power supply next to it. So you have 24 volt and 0 volt. The PLC needs a power to be energized, right? So we have to add a power supply. This I can add here. Power supply, this ideal I can add. So this is 24 volt power supply already available in the library, and I can bring it next to it. Also, I can rotate that by 90 degree. There we go. So power supply is there, PLC is there. We will do the connection shortly. What else do we need? We have one push button. So it's a momentary push button, and we need one lamp. So this lamp, I'm not sure if I have this one, but we'll see. So let's take one push button, I hope it is called. Yeah, so you have several push button, but the one which I want to use is push button NO. This is the latest push button that we have in Simumatik. So let's bring it out, and I just keep it as it was on our diagram. So let's just keep it here. One thing that you can't do is you can't show the wiring hanging around here. This might come in the more updates, but I can connect the IOs here. And the last was a lamp. So let's see, we have indicator. We can use an indicator lamp. This will also work. Or indicator light. There you go. And I can also rotate it so that it looks nicer. So far what we did, we just bring the components on the table. I'll just randomly place it here. Okay. Now if you see this diagram here, he has already wired up. Okay, so you can see how the 24 volt is going to the PLC, 0 volt from the power supply is going to the PLC, and 24 volt is going to the one end of your switch. Another end is going to the digital input, and then 0 volt is connected to PLC and also to one end of your output. And the output, the lamp is connected back to the PLC output. So this wiring you can also do in Simumatik in 3D and 2D both. So let's see both ways. So here is the 3D environment, and if I click on my power supply, you can see that it's not connected to any other port. So if I click on my PLC, I will see several variables, several parameters. I come to that later on. If you go down, you will see X1 and X2. And X1 and X2 are basically the ports for wiring this PLC. So maybe if I have a symbol here, you can see we have a symbol here, and here if I take my mouse, you can see this is X2 and this is X1. And if you open this PLC, in the description you will find X1 should have 24, X2 should have 0 volt. So I just have to connect voltages here. So X1 I can select, and from here I can see power supply, P is the positive, and X2 power supply negative. So this has been powered up. So just to verify that, if we click on start emulation, let's see, you can see that now it's powered up, power supply is also running. So PLC is powered up, and you can imagine if I don't connect X1 or X2, let's disconnect X1, then you will see PLC is not powered up. So you can also do some troubleshooting as well. So let's just connect that back to positive. So PLC is powered up. Now we need to give power to our devices. So this needs 24 volt at pin number 13. So here I will connect power supply positive, And then the output of this goes back to PLC. So I go to PLC again, and I can select input 0, 0. First input is connected to my push button NO14. So now this has been connected. Now, if you are wondering that you want to see that in 2D, you can do that from here. Just toggle this button and now drag your PLC. You can see PLC is already here, and these are the connections. So let's drag our power supply. It will automatically show the connections because we did that in 3D. So 2D will be done automatically, or you can do that in 2D and it will reflect in 3D. So now if I drag my push button, there you go. And you can see that this is connected. One end is connected to positive and the second one is connected to a PLC input. So we have a comment from Marcin. Usually even in Simulator there is no power supply connection. I'm delighted. Thank you, Marcin. I'm happy that you're delighted, because here it's much more realistic way when you are wiring up the component. You also need a power supply, and if you want you can also add some fuses, some MCBs you can also add, and you can set the rating of your current and it will trip on that current. Okay, so push button NO is connected to this one, and now what we need an indicator. So if I bring that here, it is not connected because I didn't connect that. So but I can connect that now in 2D. But it's sometimes in 2D it's a bit too much work to connect, because you have to click here X1 and then you have to bring it to this component. So my recommendation is you go to 3D and connect that here, and it makes it much easy to further on realize in 2D, because in 2D it will be made automatically. But in this indicator we can have a look if it has a preference. Yes, so X1 is 24, X2 is 0. This is what I want to check. So X1 should get now 24 volts from the PLC, which means it should has an output from the PLC, out 0. And this one should be connected to 0 volt. So now we have done the wiring. If I go to 2D again, you can see that it's connected. Okay, pretty neat. So as per Tom's exercise, we have done the wiring. So you see, it's so useful to have some exercises and a platform together to realize what you're doing. Because if you make a mistake in your wiring, you can't expect good result with the programming, because the wiring is incorrect. So the first step is always to verify if the wiring is correctly done or not. Now let's come to the exercise. What Tom wants: turn on light in lamp with a push button. The exercise has a push button switch S1, this is your S1, and a lamp P1 connected to the PLC. We did that. The push button S1 is connected to digital input module. We did that. The lamp P1 is connected to digital output module. Now here they have modules of PLC, but I used a PLC which has inbuilt IOs. We also have modular PLC in Simumatik where you can connect IO modules, but just for sake of explanation, I used my generic PLC. The requirement is if the lamp P1 is turned on, S1 is pressed. The lamp P1 is turned off when S1 is not pressed. So basically with the switch you turn on and off the lamp. Very easy, like I said in the beginning. So now everything is done. What we need to do is we need a programming platform. So for that I'm going to use CODESYS. So here I have my CODESYS. So in CODESYS I can start a new project. It's very simple. You can go to File, New Project, and here I'm going to select a standard project. Here I can type PLC exercise. Let's see, what is the exercise number? 2.1. Name of your project. And then it will ask you about the programming language. So let's say for this lesson, I will use a very simple ladder logic. This is what many of us are familiar with. Okay. So we have a PLC defined here, and this is your PLC program. So to communicate Simumatik and CODESYS, there are some steps required. First is you need to have a global variable defined. In this case, you can right click on your application, add object, and select global variable list. I will keep the name as default and add. So now you have variable global defined here, and inside this variable I have to define some variables. Now why do I need to do that? If you look at my PLC here, it has some variables which are initialized with none. Okay, and we are working with digital input 1. Okay, it has digital input 1, digital input 2. So digital input 1 are basically these 8 inputs. Digital input 2 are these another 8 inputs. So it has 2 modules, inbuilt modules. Similarly, digital output 1 and output 2, 8 outputs here, 8 outputs here. Okay, so first we need to do is we need to define a name here. I will call it inputs 01. Okay, this is just a name in string, inputs 01. The same name I have to give in my CODESYS. So I will call this variables inputs 01, and the data type will be byte because we have 8 inputs. And now we have to do the same for the outputs because we are turning on the lamp. So here you can write outputs 01, and back to CODESYS, you can write outputs 01 byte. Okay, so you have input outputs defined in your global variables. Now you need to add a symbol configurator because the mode of communication between Simumatik and CODESYS will be OPC UA. So you need to have some way to communicate with each other. So here you can see I have different drivers. So I have OPC UA, Modbus, MQTT, Omron. So I will use OPC UA because CODESYS has a soft PLC which can be communicated by OPC UA. So if you see here, my soft PLC might be already running. If not, I can start that. So if you type CODESYS control win v3, this is your soft PLC running here. I have a question, okay, from Marcin. I need to tell that to my manager about Simumatik. Sure, I mean, if your manager needs a demo, I'm always there for you. I'm working for Simumatik as well as a content creator, so feel free to tag me for that or write me for that. Tom, can you use other PLC platform than CODESYS to write the PLC program? Yes, you can use any platform you like because in the end, we are driver specific. So if any other PLC supports OPC UA, you can use that. If any other PLC supports Modbus, you can use that. In fact, if I show you simumatik.com, and here we have an academy, and this academy I am building myself. I'm writing a lot of content for this academy. And if you go to the courses, we have a course called Gateway and Integration. And there you can see different types of hardware or software PLCs you can connect. So you can connect Ellen Bradley, hardware PLCs, Arduino, Opta, Automation Studio, CCW, CODESYS, PLC Next, Rockwell, Siemens. So a lot of PLCs are supported based on the protocol. Not only just PLC, we also support robots. So I know you have some of the exercise with robots, Tom. I'm going to use that as well. It will be a lot of work to program the robot because I have to program the motion first. So maybe I will use URSim or I don't know, maybe RobotDK. And then I have to realize your exercise using some robot integration. Maybe it's also fun for you to watch. And not only that, you can also do some IoT tools integration like MQTT, Broker, or you can connect via Python and UDP driver as well. So any other question, Tom? Okay. Great, so coming back here. So like I said, I'm going to connect via OPC UA. So here I have to enter my IP address, which is actually localhost, because my CODESYS is running in my computer. So I put 127.0.0.1 and variables are defined. Looks great. Coming back to CODESYS, here I'm going to add a symbol configurator, which is over here. This will allow you to build OPC UA connection. So by adding that here, now what you have to do is click on build, and here, wait a second, go back to GVL, go to properties and make sure you check this link always. So this has to be linked. And then let's see if you can find, now you can see GVL is here. This we have to check, and now these tags are linked to the OPC UA server. And one more step you have to do, once you go to your device, here you see you have a gateway. Just click on scan network and this will tell you, oh, now I have 2 instances running. Sorry about that. I didn't see the other one before. I can close the instance, both of them, to avoid any confusion, and start the instance again. So this is like a soft PLC instance. And let's scan that again. Now you have this instance. This is coming because this is running here. Where did it go? Here is the instance. And if you notice, if you go up, you will see your OPC UA server details here. All right, with the port address and your endpoint. So just double click on that. And once you do that for the first time, it will ask you to enter your ID and password. So I'm just going to use the one which I decided before. So you can select which ID and password you need. Now your device is active. Now in this case, you have to deal with the security. You know, in OPC UA, we have a security with ID and password or sometimes certificates. In this case, I'm going to change the policy. I will say, make sure you have allow anonymous login. So this will make my connection super easy to connect with Simumatik. Once this is done, just go to login and download your code into your soft PLC. So in a few seconds, the code is downloaded. PLC is in the stop mode. Let's go to the run mode. And now we are in the run mode. So I didn't write the logic yet. I'm just showing you the communication. So here, the endpoint is defined, URL and port number is correct, variables are correct. For the outputs, I have to write outputs 01, and it should be working now. So we have our input is connected, our output is also connected. Let's see. Now, next step is just connect the gateway, and we should be ready to go. So let's see if it's working. So you can see that in info, it says variable found. This is like a feedback that we are connected and it found the variable status is running. All right. So the wiring part, communication part is done. Now we come to the exercise, which Tom wanted us to do. Start the output with an input. Super easy. So in this case, you can go to your PLC program. And because I took the ladder logic, which I never used on CODESYS before, to be honest. So I have to see how to use ladder logic. I believe this is your input contact. I've used ladder logic in other programs, but CODESYS I usually do structured text. And this output should come here. Okay, this looks nice. And we have an input and output. Now input actually, now how the input is going to come here. We have connected the variables. So if I show you like this, I will make it 50-50. Here and here. So we have variables for inputs for this whole module, which was inputs 01, which we define in the global variables. Okay. So what you can also do is you can just go here. Let me just go. Oh, sorry, I'm offline. I can just type inputs. First, you have to type GVL because it's global variables. Input 01. Dot 0. This is your first input, okay? Because this is connected to my first input. So if you see here, if I press this button, this input is on. So we also have this LED to show you if input is turned on or not, right? This input is here. And then we need an output. Output was out 0, this one. Here I can just type GVL dot outputs dot 0. That's it. Let's download that and see if it works. There you go. It's downloaded. We have to make sure PLC is in run mode. Now it's in run mode. Both are false. Let's see if it works. There you go. It works, but the LED is not on. Let's see why it is not on. GVL. Output 01. There might be something I'm missing. Oh, there was no outputs here. I thought I write it. So output 01 is my digital output. Let's reset and start again. There you go. And now you can see that the output is on by turning on the input. I hope this was your objective, Tom, for your exercise. Very simple. When you press the button, output should be on. When you release, it should be off. Some questions here. Could you please, Rajvir, do a special lesson with CODESYS on your code and compile platform? Very good question. In fact, I am preparing for my next course, which is on CODESYS. Because I have so many hardware, I have so many edge devices which supports CODESYS. I have one from Turk, I have from Revolution Pi. I have one from Vago, I have from ControlX Core, and I have from PLC Next, where you can run CODESYS. So it's my plan to use CODESYS as the base course so that you can work on these edge devices. Marcin, I'm going back to university in Scotland soon, and this is a perfect for Simumatik, especially for troubleshooting. Yes, that's great, Marcin. I think if you like this platform, actually, I just showed you the PLC project. There is much more you can do. This is just 0.1% of what Simumatik can do. In the next live streaming, you will see how you can run conveyors, how you can have sensors, how you can do robots, how you can do virtual commissioning, and linear drives, motion control blocks. You can do a lot with Simumatik. Thank you, Tom, for your feedback that I passed the exercise. All right, now because we have already set up this Simumatik here, next exercise will be much faster. This I promise you. Let's go to the next exercise. Turn on the lamp with 2 push buttons. Now you have 2 push buttons, so we need to add one more push button inside our environment. In this case, the easiest way is select the push button, and let me just bring these panels here. Select these 3 dots here and duplicate that. Super easy. And just for the sake of understanding, I will rename that to IN0 and this one to IN1. You might be wondering, where is IN1 actually? IN1 is actually on top of that, so I can bring it down. So now you have this IN1. This needs to be connected to the PLC. So in this case, you can see that IN0 is connected, IN1 needs connection, so I can connect that to PLC input. Where is that? Oh, this is actually what is this? Is the different connection. This is the positive power supply, and that other one is PLC. So first it needs a power supply. And the PLC connection, you can go to PLC and then connect the button, not the other way. So here, now IN1 is already connected. So wiring is done. Just to verify, this is IN0, you can see LEDs on, and this is IN1. Okay, now we have to change the program. If both the buttons are pressed, then only indicator should be on. So here what I can do is I can go offline. I can copy paste another contact and change the addressing to 1. So when you have to press both, it means it's an AND gate. Okay, both should be pressed and then output should be on. So you can either write an if-else statement, you can write an FBD, in ladder logic you can do like this. And now let's go download this logic and see if it works. Now there's one limitation here because I can't press them together. There's only one button you can interact. Okay, in this case what I will do is I will try to see if I can, here you can see we have an option to maybe use it as maintained. Okay, although it's not the part of exercise, but to show you the logic, I can use it as maintained. So in this case, now let's hide that, and when I press this is now maintained. So this input is true. Second input, I can turn it on here and my lamp is on. So this is not, this is just a trick to realize this exercise that you have to press both buttons, okay? Because I can't do that with my finger, 2 fingers in my platform. So I have to use it as a maintained. So I hope you will understand why I did that. This was the exercise 2.2. When 2 push buttons are pressed, then the output should be on. I hope it was what you expected. Another comment, you can also write in ST programming. Yes, Tom, we can write in ST programming. You can choose any programming platform you want, because this live streaming is for the beginners, and I know a lot of people who are familiar with relay logic, who don't know PLC before. They are much familiar when I work with ladder logic. In some of the exercises, I will use combination of both. I will use some logic in ST, some in FBD, some in ladder, so that you can understand where you can use which one. Marcin, you wrote, you have a different dosage of substance also in Simumatik. Now I work for a water company and it's possible to... Okay, I will answer your question in the end, Marcin. It's a question unrelated at the moment. So heading on to the next exercise, turn off light in lamp with a push button. When button S2 is pressed, lamp should be turned off. When S2 is not pressed, lamp should remain on. So it's basically like inverse logic. So very simple. We have to use just one button. We have to just use the NC of that. Okay, so let's reset the emulation. I bring this button back to normal state, and that's all we need. Now in this case, I remove this button. We don't need. Let's go first offline. And here I just need to use the NC. Okay, that's it. So maybe let's see how I can do that here. Negate. Yeah, you can use negate. Now it's the NC of the first input. Let's see now. Download. There you go. It's running, and start the emulation. And you can see that when the button is not pressed, the output is true because it's NC, it's already passing the signal. And when the button is pressed, it will open this NC contact, and that's why output is false. Super easy. So, Trinat, hello. Nice that you have, nice that you joined as well. So this was the exercise 2.3. Okay, let's begin. Turn on light with one of the two push buttons. This is like an OR gate in which you press any of the button, the output should be on. So write a PLC program where lamp P1 is turned on when either push button S1 or push button S2 is pressed. So basically it's an OR gate. So you can imagine a situation where you have one output and you have multiple locations to turn on the output, so that you don't have to go for one button to always turn it on. You can connect another button in the parallel to turn on the output. So this is actually super easy. Go offline and make it normal contact, and I need a contact below this one. So this I can bring here. Okay, this I have to have under this. This I need to know how this had happened in CODESYS. I know in different platform to connect that here. So CODESYS, ladder logic, I'm not so familiar. Ah, maybe like, no, not like this. How do you do that? In parallel. Oh, there you go. Under this arrow. And then you can maybe connect it like this. There you go. You learn by doing. So now we need any of this button should be pressed, the output should be on. So I already have the address of the first one here. I can take the second one here. So first address is 0, second is 1, and there you go. That's it. That's all you have to do. Right mouse click. Thank you, Tom. Better to negate output instead of input. So Tom has a recommendation that you can negate output instead of negating input. This will also solve the problem. So right now you have two inputs now. So if you press any of the input, the output should be true. So in this case, there you can see that output is true, and this is actuating the ladder on the parallel ladder. Okay, and this one is actuating this one. So with both inputs, the output is true. Super easy to realize, and along with the wiring, I think it's super fun to do. All right, moving on. Turn on two lamps with a rotary switch. In this exercise, a rotary switch is connected to a digital input, and two lamps are connected to separate digital outputs. Write a PLC program. If a rotary switch S1 is in position 1, both lamps should be turned on. If the switch is position 0, both lamps should be turned off. So we have to actuate both lamps together and turn off as well with the switch. So in this case, we need a switch. You call it rotary switch. There are different names you can call it. I think in our library, we call it just switch. I need to check. Yeah, we have a 2-position switch. Okay, so I will use 2-position switch and load that in my environment. Let's bring it up here, and let's rotate that. So you can also have a small box where you can organize the buttons, but this is taking a lot of time, so I will not do that right now. So I will just take the switch, and now the switch, as per the exercise, is connected to the first input. Okay, but if you don't want to disconnect these two inputs, you can also connect this one to the next available inputs. Okay, I will do that so that I don't have to disconnect my other inputs. So this one I will connect to the next input in 2. Okay, so first this switch also need a power supply for 24 volts, which you can also see in this diagram, that this switch has one connection to 24 volts and another one going to the PLC, right? So one is connected to 24 volts, and I select PLC now and go down. Next input is IN02. This is empty. I can connect to position output 14. Okay, so this is connected. Now I need another lamp, so I can right click, not right click, I can select this one and duplicate that. And just for the sake of understanding, I will rename that to out0. Rename out0. And the other one, rename to out1. So here you can also see you can change the color of the lamp based on if it's true or false. So let's bring it here, and now out1 I'm going to change the color just to show you the possibilities. Color off, I will say it's gray, and color on, I want green in this case. Let's take a little bit green. Okay, now colors are defined. And one more time, let me see and confirm. X1 was 24 volt. So this should be connected to the PLC output. Now PLC output out0 is already used. I will connect that to out1. So in this case, out1 I can use here, and this will connect again to 0 volt from the power supply. Okay, connection is done. And now this is my out1, and this is my input 3, and this is my out0. So once I turn it on, both the outputs should be on. That's the task. Let's go offline. And now we need an output in parallel, because you need to turn on both the outputs. In this case, let's see if I can do that. I will copy paste. Copy paste doesn't work. Where is the output? I can take, it's faded. I need your help, Tom, if you're there. One more time. This, or maybe like this. Shortcut. All right. So I just copy paste the network and bring the output here. Then you can connect your second output. The address is 1 because I connected this output to the out1. Okay, so out0 was there already, out1 is there, and this input is now IN2. It's connected here. Just to verify, let's check it out if it's working. There you go. It's IN2, right? So let's change that. 2. And let's download this code. Run the PLC and let's start. There you go. Once you turn on the switch, both the outputs are true, and with this off, both the outputs are false. So I hope I did it right. This was what it was asked. S1 is controlling both the lamps. Okay, super easy. Let's continue. Now it's 2.6. Turn on and off lamps with the push button. Write a program that operates as follows. When push button is pressed, lamp P1 should be turned off. This is off. And P2 should be turned on. So when push button is pressed, P2 is on and P1 is off. When push button is not pressed, lamp P1 should be on and lamp P2 should be off. So it's basically with one state of input, one output is on, another is off. With another state of input, another is on and the first one is off. Okay, thanks Tom. Right mouse click. Okay, let's begin. In this case, Tom, I can negate the output like you recommended. So let's go back. Now in this case, we have a push button, which we already have in our environment. And we have 2 lamps as well. So we can just work on the program. So input is connected to 0. First push button is connected to 0, which is this one. With this one, I can negate it. I hope like this. Yes, I can do that. I can negate the output. So let me see one more time. If S button is pressed, P1 should be off. If it is not pressed, P1 should be on. So that's correct. If it is not pressed, this should be on and this should be off. If it is pressed, this is off and this is on. So this should work. Let's try that. So I have to, whenever I'm downloading the logic, I have to reset the emulation. Otherwise it will throw an error because it's restarting the OPC UA server. And let's start the emulation. And now you can see that the first output is on if it is not pressed. So when S1 is not pressed, P1 is on and P2 is off. So P2 is off, P1 is on. When this is pressed, this is on and this is off. Right? Super easy. Thank you, Tom, for this beginner exercises. It's really helped the others who have never programmed the PLC to understand about NO and NC inputs and also negation in the outputs. Next question, turn on lamp with 2 push buttons. Here are 2 push buttons, S1 and S2, and lamp P1 connected to the PLC. All right, so the lamp P1 should be turned on if either push button S1 or S2 is pressed. If both push buttons are pressed, the lamp should be off. So if both are pressed, lamp should also be turned on. So this is similar to one exercise we did before. Should be turned on if either the button. So if you press any, this is NC, all right. So in this case now, it's similar to the last exercise, but here the switch to is NC, okay? But here the execution should be the same. If any of this button is pressed, output should be true. And if both the buttons are pressed, the output should also be true. How can we solve that? It's a bit tricky. Let's see. So we have push buttons IN1 and IN2 connected, and the lamp is already connected. So in this case, we don't need another output, and this I can bring it normal. So if this is pressed, and so this should be in the parallel, right click, and insert, okay, maybe, yeah, insert like this. Oops, I have to connect it here. All right, so this was my second input. First, let's give the address. So this is my NC, this is my NO. So first in our Simumatik, we have to have an NC button. So this, I need to change that to NC. In this case, I can maybe just remove this one, or let me see if we can do that directly. I doubt that. No, we have to remove this one and add an NC button. I go to my public library and maybe just type NC. You should have an NC push button. There you go. This is with light. This is without light. So NC button is here. So because it's an NC button, I will change its color to red. And this one I can change to green. So you can see that the color option is here. And I can select green color for this NO, just to differentiate that, and red color for NC. This should be fine. Let's verify first its operation on the PLC. Okay, now because I took this button, I have to connect that as well. So here I give 24 volts first. And then PLC input should be 1. So let's verify its function. Now you can see that this is NC, so that's why it's already true. And this is NO, which is making it true. Now comes to the question. It says when push button S1, if either of the push button is pressed, P1 should be turned on. So when you press this one, this will turn on the output. If you press this one and don't press this one, it will do the opposite. So we have to take an NC here. So negate that. Second situation, if both push buttons are pressed at the same time, the lamp should also be turned on. This will also work if both of them are pressed. And if either of them are pressed, let me just verify, this will turn it on, and let's see if this works. You can always check easily your logic if it's working or not by having a simulator next to it. So there we go. So here, none of them is pressed and output is off. So I press this one, output is true. I press this one, output is true. Okay. And now if both of them are pressed, which I can't do like I told you before, but if you realize that if I press in any situation, the output will be true. Okay. I hope this is what you asked, Tom. This was a bit tricky, but yeah, I hope this is working good. Okay, let's move on to the next one. Turn on lamp with 2 push buttons. Now you have a tower light here. If you notice here, you have a lamp with 3 outputs. And you have 2 NO push buttons. When button S1 is pressed, the lamp P1 should be turned on. When button S2 is pressed, the lamp P2 should be turned on. And when both are pressed at the same time, P1, P2 should be turned off. Okay, so a lot of situations, but first let's build the circuit. So in this case, we have 2 NO push buttons. I will take away my NC. Let me see if I'm using NC in the next exercise. Okay, I'm using NC as well. I keep the NC here because I need to use it later on. I will duplicate this one. NO push button, duplicate. This is INO copy, rename. Let's connect that to IN1. And the push button, let's rename that to IN2. Okay. Now we have 2 push buttons, NO type and a tower lamp. So I don't need these lamps now. Maybe I can keep it aside. And we have a tower lamp in our library. Let's bring it there. I think you can call it tower. No, not tower. I forgot the name that we have for that. Let's see in electric. You can see we have a lot of sensors, circuit breakers, more sensors, contactor, relay, motors. I'm looking, there we go. Light beacon we have. We call it light beacon, 4 colors. So I hope this is more realistic than 3 lamps on the table. I have this light beacon. I can make it like this. So this one is here. And these 2 we don't need at the moment. I can hide them. This I can also hide. This I can also hide. So we have 2 push buttons and a light beacon. All right. This light beacon has 3 in our exercise, but here we have 4, but that's fine, right? So here you can see there are connections here. This is the symbol, and this is X0. Oh, Tom, Tom says very fine lamp tower. Thank you, Tom. Actually, we are also planning to build a component which works on IO-Link, so you can also control IO-Link based components. And you can also do the fading. You can do the level in your light as well. So these are under development. So this light beacon, we have to check the component details first. So X0 should get 0 volt from the power supply. And then X1, X2, X3, X4 are defining different colors: blue, green, yellow, and red. So we can use red, yellow, and green, which is X4, 3, and 2. Instead of blue light, because I believe here you have 3, which could be red, yellow, and green. So I will not use the X1, I will use 2, 3, and 4, and X0, 0 volt. So X0 should get for 0 volts from our power supply, and X4 is the one, I think is the X4 is the red light. Let me check that again. Yeah, X4 is the red light. So this is X4, X3, and X2. So X4 I will connect to the next available output. So PLC output I can take 2. So out 2, and then the yellow light is out 3, and then the green light is out 4. So out 2, 3, and 4 are my 3 outputs for P1, P2, and P3. Okay, because other outputs are connected. Okay, so wiring is done. Now coming to the program and see what does Tom wants here. Let's go offline. Delete this one. All right. When button S1 is pressed, lamp P1 should be turned on. So S1 is, let's say my S1 is connected to, let me verify one more time. Okay, one is not connected at all. This is connected to IN0. Next one I can connect to IN1. So power supply positive and PLC IN1 is connected to something else. I can change that. IN1. So this is my IN1. Right. Now I have IN0, IN1 connected. So S1 is IN0 is pressed, lamp P1 should be turned on. P1 is red, and red was X4, which is connected to out2. Okay. When S2 is pressed, lamp P2 should be turned on. Let's copy paste this one. Second input, second next output, which is 3. When both buttons are pressed at the same time, P1 and P2 should be turned off. All right, so this was P1 and P2. If they're pressed together, then these should be off. It's kind of like interlocking. When both buttons are pressed at the same time, P3 should be turned on. Okay, so another output. Let's solve the last one, which is straightforward. So you can have another input here. I can take another input and I can call it GVL input.0. When both are pressed, then your another lamp should be on, which is 4. But when both are pressed, these two should be off. So kind of like an interlocking. So what you can do is you can interlock these inputs and put their negate function here. So its negate function here and this negate function here. So they can turn off each other's. So in this case, I can have here an contact and make it negate and change its address to 1. So its NC contact is here, and NC contact of this input I will connect here. Negate. All right, I hope this is the solution. Let's try. Let me know, Tom, if it's correct. You are the supervisor here today. Okay, let's go start the emulation. And let's verify now the conditions. So the condition was if first input is pressed, one output is true. So this is turning, the switch is turning on, out 3. This was turning on the first one. Now when I press both, green should be on and these should remain off. So in this case, if I have to press both again, I have to make sure one of them is maintained, otherwise I can't realize this exercise. I will make them maintained, start emulation. Let's try now. So I press the other one. Now you can see that first two outputs are off and the next one is true. This happened because you can see in the logic, I put some NC contact of inputs in front of another input. So it will allow only, it will disconnect the output. So yes, still here. Thank you, Tom. So this is correct as well. And this is very interesting. And with these exercises, I realize now, with these tiny exercises, you can understand the function of using NC contacts in your ladder logic or in your FBD or in your structure text. So very interesting, Tom, the way you are putting up these exercises one by one to show the function of NO and NC everywhere. Okay, this is done. Let's see what we can cover. We have still 5 minutes, not too much time. So maybe the next exercises I will continue in the next live streaming, but I want to show you before you go. Here is another lamp tower. Okay, maybe this you can take as a homework. If you can solve this exercise by yourself, just write it down on a paper or if you have Simumatik, you can realize that there, or any other simulator, you can try that. But what I wanted to show you, the exercise of conveyors, which I'm going to do next time. And Tom, I wanted to surprise you if you're still here. I created a lift table to realize this exercise. I wanted to show you that because this is what I'm going to cover in the next live streaming. So here I can reset emulation, and I want to show you what I already did. I can maybe load the whole system. So I created a pallet lift table for that exercise. So here you can see that this is the pallet lift table, and I hope it's quite realistic to what you wanted people to experience or try. So here is the pallet lift table. So you have two buttons here on the bottom. You press the button, it will open up. You press the other button, it will close. And then you have some sensors here, and this is controlled by a motor. So this pallet button is actually from one of our component, which was AGV. We were making some AGVs. We can also do AGVs in Simumatik. And I asked one of my developers, hey, I want to use that for one of the Tom's exercise. He said, yeah, go ahead, work on that. So I remove actually all the tires and to move the AGV. So I just made a very simple concept of moving up and down. So if I maybe let me start the emulation. Everything broke down. I think this broke down because I have my other test bench also in the same area. So I have to remove this. But you can imagine the realistic behavior when you have physics enabled. So now you can see I start the emulation, and I still need to build a PLC panel, and I need to connect the wiring. But here I was just doing the testing. Let me see if it has a PLC. Okay, so I just connected the motor directly. So if I press this button here, you can see it's going up. It's pulling it up, and this is bringing it down. So I have these switches floating in my area. This is just for testing, but later on I'm going to show you how you can connect that to PLC and actuate the motor. And in this palette, I think we also have the sensors, which I already programmed. Yeah, you can see that the sensor lift up. It's 24 volts. It's true because it's lifted up. And if I bring it down, then okay, this is not properly programmed, so I have to program again. This was actually, I was working on that, but I did not finish it. So I have to program the sensors, how the sensor is going to actuate true and false with the position of the pallet. This I will do next time. But I will show you how you can solve this exercise which Tom asked you in this digital twin. All right. So this was about today's live streaming. I hope you like this. I hope you could follow me and follow these exercises, but this is just the beginning. We'll be doing some complex exercises as well later on. And if you are interested, go ahead, and if you want to solve this exercise yourself, you can buy Tom's book. This book is really interesting, how he's challenging you to solve the exercises. I did not solve that before. I just do it on live, and sometimes I'm a bit nervous and making mistakes. But yeah, everything went well. Thank you, Tom, for your presence. And let me see, what questions do you have now? Khan, hey Rajvir, what is an AGV? AGV is an automated guided vehicle. So it's a vehicle which can run by itself. And how does it run by itself? Because it has a controller which is taking the commands that you feed inside the AGV. And then it will find a path where it has to go with a lot of sensors around it so that it will not collide with other equipments or persons. So it knows which path it has to follow, and with safety for sure. Tom, it is always okay to change the exercise to fit the components you have. Very good. Okay, Tom, yeah, totally. But I really wanted to follow what you wanted to teach to the students or challenge them. But yeah, feel free, if you're using Simumatik, you can change the exercise, you can modify that, or you can also optimize, add some more sensors and make it more decorative. And if I didn't show in my presentation, there are some exercises which I find really interesting regarding the tank of mixing, tank control, level control in the tank, and the pallet control you have, which I want to try. With conveyors, I really wanted to try what I can do. And some with robots. And I also see one drilling machine you have, one car parking you have, also very interesting, but I don't know if I can do car parking. I will try my best to realize all these exercises. So if you are watching until here, Feel free to subscribe, and I will see you soon in the next live streaming. Until then, if you have any questions, feel free to ask me. Tom says there's an exercise on page 94 with AGV. Okay, maybe I didn't go that far already. Oh yeah, there is an exercise with AGV, which is delivering, I hope, products to different cells. This I can realize. So this I think I will program with ROS. With ROS, you can program the AGVs and give the positions or the location where your AGV should go. And then I can try to simulate what he's asking here. Super cool. So go ahead, buy this book, subscribe to Simumatik, subscribe to Code and Compile, and hopefully I'll see you in your next live stream. The updates about the live stream you can find on my LinkedIn, so feel free to follow me and to get more updates about our live stream. All right, thank you and have a nice day. Bye-bye.